So first, thanks a lot for the invitation, for being here. And it's a very interesting meeting for me, very different to what I'm used to as a scientist. And actually, when I was flying here from England, I was trying to remember when was the last time I have been in Austria. I haven't been to Linz before, so it was a nice surprise to be here. And I saw, well, maybe like about 10 years ago, I came to a conference. Well, I went to a conference in Wien, and I think I have spent like, I don't know, 5 days or so in a conference. And then I was trying to remember, so talking about memory, what do I remember from this time, from this visit to Wien? And I remember, of course, schnitzel. Yeah, first thing, I had schnitzel with citrone, with lemon. The other thing I remember, I mean, if you have been in Wien, you won't forget that these guys or girls dress up with 18th century costumes, selling you tickets for the opera, which is quite remarkable. I found it very, very interesting. And I remember being in a very old cafe and thinking, well, I mean, like this has 100 years old. I mean, I don't know, several hundred years old. So how people would have been a couple hundred years ago. And now the interesting point is, talking about memory, if I want to tell you more about my 5 days in Wien, I can't, right? I just don't remember more. So if you force me, if you give me like 1 year to think, okay, now let's think hard, what have you done in Wien? You have to remember more. Well, maybe I will remember 2, 3 more things, but that will be it. And basically I told you in half a minute all what I remember from around 5 days that I spent in Wien. No? Each day with 24 hours, each hour with 3,600 seconds, no? And that's it. The rest is gone. So that's the first interesting thing, how very little we remember. And the second very interesting point, which is not that obvious, is that we tend to remember concepts, right? So I remember being in a cafe in Wien, and I remember that was an old cafe. I don't remember the name. I don't remember exactly where it was. I think it was close to the cathedral, but I don't remember much about the cafe. I just remember I was in an old cafe. I remember having schnitzel, but I don't remember where. I don't remember the restaurant. I don't remember any of the circumstances of having a schnitzel. I just remember this concept. I remember I did have schnitzel, and so on. So basically in neuroscience, I mean, I'm a neuroscientist, so we try to understand how processes as such work. How do we remember? How do we see? How do we make decisions? How do we feel? And so on. And basically we're interested in knowing how neurons in the brain do these processes, or populations of neurons, bunch of them, how do they work together to do these processes? But I won't tell you much about this. I won't tell you much about my research. I just want to talk about this guy, who I think was an amazing thinker from last century. Jorge Luis Borges. Jorge Luis Borges was an Argentinian writer, and if you never heard of him, I can tell you very briefly. Of course, I'm very subjective, or very objective if you want. He was perhaps the best writer in Spanish in the 20th century, right? And there were many, many good ones, but I think most critics, literary critics, will rank him at least among the tops, if not the top. So he had a very particular type of writing. He never wrote a novel. He never wrote long stories. He always wrote either essays or commentaries of other books. I mean, he knew a lot about literature, and he wrote short stories. So all his stories will be around 10 pages, between 10 and 20 pages, right? Very easy to read, very engaging. From the very first sentence on, you can read any of his stories. And if there's something that is very peculiar about Borges, is that his stories always leave you thinking. There's always some deep thought on these stories, or nearly always, right? And in 1941, he wrote a story that has a lot to do with this session and actually with this whole festival. And he published this story in a newspaper called La Nación. It's a very famous newspaper in Argentina, and that's in the middle of the newspaper, not in the cover. And the story is called Funes el Memorioso, Funes de Memorios. And it's actually about a guy that just cannot forget, that will remember absolutely everything. So how about that for Total Recall, right? A guy that will not forget a single bit of anything. And Borges tells the story, and what happens is that this guy, Ireneo Funes, is, let's call it a gaucho from the Pampas, from a small city called Fray Bentos. And one day he falls from his horse, he hit his head very badly, and he recovers consciousness with amazing talent, or curse, as you may take it after a few slides, of remembering absolutely everything. And compare it to my records of being. Borges said in the story that Funes once tried to recapitulate one day, and it took him exactly one day, because he didn't forget a single bit of the day. Funes saw a tree, and he just did not remember every single leaf and every single branch of the tree. He remembered every single time he has seen the tree from every single angle and under every circumstance. So I tell you, rather than me telling you what Borges said, let's just read a couple of sentences about what is to be like Funes, to remember absolutely everything. So Borges said, "We at a stroke perceive 3 cups lying on a table. Funes will see all the shoots and clusters and fruit comprised by a vine. He knew the shapes of the southern clouds at dawn of April 30, 1882, and could compare them in his memory with the streaks of a book of Spanish cover that he has seen only once, and with the swirls on the foam raised by an oar in the Rio Negro on the eve of the Battle of the Quebracho." So the guy will remember every single thing in excruciating detail. He will not forget anything. So he ended up his days in the story being somehow recluded in his room, a small room in darkness, and laying in a corner without even looking at the single window. And Borges came up with the conclusion, which for me was brilliant. That's the genius of Borges. And look what he said. Funes said in the story, said to the narrator, which is Borges, "I alone had more memories than all the men may have ever had since the world exists. My memory, sir, is like a rubbish heap." And that's the key. And that's the brilliancy of Borges. As in many of the stories, I think that's the brilliancy in this story. So Borges had it very clearly that if we will remember everything, it won't be good. Although we want to remember sometimes, no? I mean, sometimes I say, well, it's a pity. Maybe I had a really great time in Vienna and I want to remember more. Or I want to remember more from my childhood, so many nice memories. I want to have more of that. But if we remember too much, maybe it's not that good, right? Or if we end up in extreme cases of total recall, like Funes. And about, 3-4 years ago, I was very intrigued by that. And I thought, well, that's really brilliant. And how did Borges come up with such an idea? That if you remember too much, I mean, you end up alienated somehow. We all want to remember more. We all complain that we forget things. So how he came up with the opposite idea? And I tried to explore what did Borges know about memory? What did he know about neuroscience and so on? And the first thing is already in the story. The first thing is already in the story Funes de Memorios. And Borges refers in the story to the first encyclopedia in history, and that's called the Naturalis Historia. And that's an encyclopedia written by Plinius, Caius Plinius II, Plinius the Elder, also called, more or less at the time of Christ, and describes in many books everything that was known about the Roman Empire at the time. So there will be one chapter for agriculture, one chapter for soldiers, one chapter for wars, one chapter for geography, and so on. And in chapter 24 of book 7, Plinio described cases of extraordinary memory. And then he described the case of King Cyrus of Persia, who remembered the name of all his soldiers. Somebody called Mithridates Eupatus, who can speak the 22 languages of his kingdom. Simonides, inventor of mnemotechnic. Another guy called Charmadas, the Greek, who can recite a book from memory as if he was reading it. And Borges knew very well this Naturalis Historia. He was a big fan of encyclopedias, and he had this Naturalis Historia, several editions actually, in his personal library. So, and as I say, I mean, he refers to this in Funes de Memorios. So there are cases in history of people with outstanding memory, but then you may wonder, well, is it really true that King Cyrus of Persia knew the name of every single soldier of his empire? I mean, the Persian Empire was quite big, right? So one can say, well, maybe that was exaggeration. And especially if you read other chapters of the Naturalis Historia, there's a chapter about vision, and Pliny describes a guy that had such a vision that wrote the Iliad of Homer with such a tiny letter that he can put the paper together in a nutshell. So, of course, I mean, it's a bit of an exaggeration. So, but then do we have in science, do we have scientific cases that we know of people with extraordinary memory, with total recall, if you want to call it, or close to total recall, coming close to that? And of course, these things of Plinio we cannot take very seriously. So let me tell you a story about another person, and this person is called Solomon Shereshevsky, and was studied by perhaps one of the most brightest psychologists in Russia, called Alexander Luria. And Alexander Luria, in the 1920s, he was a young psychologist just finishing his study. He was seeing patients, and one day comes to him a guy called Solomon Shereshevsky. And it's this guy that you see there. And Luria asks him, so what's the problem? And Shereshevsky says, I can't forget. And of course, imagine Luria was 20, young 20s, just got his degree and say, yeah, sure, another guy coming up with funny stories and so on. And Luria says, okay, writes in a piece of paper, write a list of numbers, 30 numbers, and say, okay, have a look at these numbers. Shereshevsky read the numbers and then could tell them back without any problem. Luria said, well, that's not bad. 50 numbers, Shereshevsky read them, could tell them back again. 70 numbers, and the list was something like this. And that's taken from the book of Luria describing this case. So the guy could read the list without any single problem. He can say any column of the list. He can tell any row. He can read it backwards. It was kind of like as he has a photography in his head of the list. He could not forget the list at all. It gets more interesting. Luria was, of course, very interested. A guy like this, we say, wow, that's quite a case. He studied Shereshevsky for 30 years. He called him patient S, right? And 15 years later, after the first encounter, he wants get him to see him again, and ask him, do you remember the first time we met? He said, yeah, of course. You were wearing this type of tie, you were wearing a lab coat, and this and that, and you were giving me all these lists. And then Luria asked him, do you remember the list I gave you to read, this very long list I gave you? And Shereshevsky could tell you the list, could tell him the list as in the first day. And Luria kept the list in his records. So he could confirm that the guy, 15 years later, was still remembering the list. So it was quite striking. He gave him these stanzas from the Divine Comedy of Dante, Nel mezzo del cammino de nostra vita, and so on. That's Italian, of course, right? And it may sound not that hard for you, but for a Russian speaker, this sounds very, very hard to remember. He could say it exactly with the right intonation, and he could say it again many years later. He gave him this very strambotic formula that has absolutely no meaning. He could repeat the formula, he could write it down without any problem, and he could repeat it, I think it was 7 years later. He asked him, do you remember the formula? Yeah, he could write it down again. And this is the hardest. This is very hard memory test. It goes maba, nasa, naba, nasa, na, maba, and so on. It's very hard because you tend to mix up these syllables, right? It's very hard not to confuse them. And he could say it without any problem, and he could say it again several years later. So now, starting this case, which seems to be of total recall, Luria says in a book he wrote about it called The Mind of a Mnemonist, he says, well, I just give up. And the way he writes it is very beautiful. He says, well, I fail in the easiest task you can ask a psychologist, to find the limits of somebody's memory. I just fail. I cannot find the limit of the memory of this guy. But now comes the little twist, the brilliancy of Luria. Instead of trying, really pushing harder to find the limits of the memory of this guy, he starts thinking, well, how is it to live with such a memory? And instead of doing tests, he started getting more and more interested in Shereshevsky himself. What type of problem he has with such a memory? Why did he come to him? And it turns out that Shereshevsky was somehow obsessed with this memory talent. He really didn't want that. It was driving him crazy because he turned up, he couldn't focus on one thing because another thing will come up and he cannot focus in a particular detail. It's very much like Funes. And the brilliancy of Luria is that he asked a couple of key questions. This is one, very simple thing. He asked him, can you remember this list? Shereshevsky, of course, remembered the list. He could repeat it without any problem. 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6, and so on. but did not realize that this was a list of consecutive numbers. So he just memorized it by brute force. And there are a few examples of like this. One time he gave him a list of items, as if I will say computer, well, computer not at the time, like chair, desk, water, coffee, vodka, I don't know, camera, and so on, like 100 items or so. And Shereshevsky could repeat these items without a single problem, right? No problem at all. From any position in the list, he can go forwards, backwards, and so on. Now, look how clever. Luria asked him, so of all the things that you say, which are the liquids? And he couldn't say. And the liquids, I told you, maybe are water, coffee, and vodka, right? It's very easy for us to do that. You will miss some, but you can still extract liquids. And what Luria says in his book is that Shereshevsky was quite inept at logical organization, at high-level thinking. So he had like an image imprinted in his head, but he cannot process it. And it's very similar to what Borges said. Borges said like the mind of Funes was like a garbage heap, un vaciadero de basuras. So, and then comes the interesting point. I mean, like, when Borges wrote this story, he wrote it in 1941 and published it in 1942. Did he know about Luria? Because Luria studied this patient in the 20s, right? I don't think so. Because Luria published about Shereshevsky only in 1968, right? And before Shereshevsky was unknown for the Western world. I mean, maybe some colleagues in Russia knew about Shereshevsky, but Borges was not a scientist, and he was in Argentina. So it was too far, I mean, this information to get to him. I don't think they knew of each other. So I think they came up with the same conclusion, I mean, completely different path. I mean, Borges, through his brilliancy and power of thought, of thinking about how will it be to remember everything, and Luria through doing the right thing for investigating this patient, being very clever in what to look for. But Borges knew about something else, right? This didn't come just out of the blue. Borges knew very well this guy here, and that's what psychologists will call the grandfather of psychology, William James. And William James in 1890 wrote an amazing book called Principles of Psychology, and he was really ahead of his time by far, maybe by decades or a century if you want. And look what James says in his book. James says, if we remember everything, we should be on most occasions as ill off as if we remember nothing. That's quite interesting. The paradoxical result is that one condition for remembering is that we should forget. To remember, we have to forget, right? Without totally forgetting a prodigious number of states of consciousness and momentarily forgetting a large number, we could not remember at all. So how come that Borges knew about William James? Borges was not a scientist. Borges was a writer, right? Well, he knew about William James because the brother of William James was Henry James, the famous writer. So Borges get to know about William James through reading Henry James first. Second, the father of Borges was a professor of psychology. So, and the father of Borges knew very well William James, and Borges get to know William James through him. And third, William James was also a philosopher, and Borges was very much interested in philosophy, and he actually had many books of William James in his personal library. So it was not new, but still this doesn't take off any merit of him for writing such a wonderful story. So clearly there's a benefit of forgetting, right? Now let's go to the other side. I mean, like, well, we don't want to remember all, but of course we don't want to forget all, right? We want to be able to remember some things. So as many things in life, there's a balance. There's a balance between remembering and forgetting. So we saw what happens if you have an amazing memory, right? Hypermnesia, some people call it, or total recall. Let's see what happens when the memory fails. And the guy that you see in the picture is the most famous patient in the history of science, I would say. He's the most studied patients in history, right? And that's what we know as patient HM. He died 5 years ago, and we know since then his name and his picture. These are the two pictures on the right on your screen. His name was Henry Gustav Molaison. And Henry Molaison suffered from epilepsy, very severe epilepsy, could not be controlled with drugs, with any medication. And that was really giving him really hard time. He couldn't work, he couldn't do anything at all. And he went to a surgeon that you see the picture on the left, William Scoville. And at the time, in the 1950s, William Scoville proposed him and his family, or discussed the idea with him and his family, to do a new type of surgery, which was basically to remove the hippocampus. And the hippocampus is this structure that you saw in the very beautiful pictures in the previous talk. And we basically have two hippocampi in the left side, and in the right side is about more or less at this size, but inside the brain. These are internal structures. And Scholby knew that the hippocampus is involved in seizures. He didn't think at the time that the hippocampus will have any specific relevant function for the brain. And he proposed to remove them because, I mean, the life of this guy was really miserable. There was nothing else they could do to cure him. And he couldn't keep on living like that. So Henry Molaison was 27 years old. He went to surgery. Scholby took out the hippocampus successfully. Molaison recovered consciousness. Everything seems fine. He can recognize people. He can pass the typical tests, right? He remembers who he is, where he is, and so on. He remembers Scholby. He remembers his parents, and so on. But say a new doctor comes to see him, do some testing, and the new doctor will come again, even if after 5 minutes or less, and Molaison will have no clue who this person is. So there was a big deficit. Molaison could not form new memories. He had memories from the past, but nothing new could be imprinted in his memory. And you can either read hundreds of papers about him, or you can see this movie, Memento. It's a very nice, fiction of something similar to Henry Molaison's case, HM. And this guy is taking Polaroids of people and just writing notes about things he should remember about the people because he cannot remember. So like, don't trust this guy, kill him, and so on. And I wasn't planning to show you this, but there's a nicer, even nicer idea of what it is not to have memory. And that's in this movie. My wife forced me to show the movie. He said, you cannot give the talk without showing Nemo. And I said, well, but I don't have time. And she said, well, no, but you have to show Nemo. It's the right audience to show Nemo. So, well, here we go. So you know the movie, right? So Finding Nemo, the little orange fish is Marvin, and his son Nemo is gone, and he's trying to find Marvin, and suddenly he gets to meet, I think it's Dory, the name, Dory, in the blue fish, who seems to have a problem. And Nemo is desperate to know where his son went and to follow his son. So let's see if the sound works.
No, they took him away. I have to find the boat.
A boat? Hey, I've seen a boat.
You have?
Uh-huh, and it passed by not too long ago.
A white one?
Hi, I'm Dory.
Where? Which way?
Oh. It went, this way. It went this way. Follow me.
Thank you so much.
No problem. Will you quit it?
What?
I'm trying to swim here. What, the ocean isn't big enough for you or something like that?
Huh?
You got a problem, buddy? Huh? Do you? You want a piece of me? Yeah. Ooh, I'm scared now. What?
Wait a minute.
Stop following me, okay?
What are you talking about? You're showing me which way the boat went.
A boat? Hey, I've seen a boat. It passed by not too long ago. It went, this way. It went this way. Follow me.
Wait a minute. What is going on? You already told me which way the boat was going.
I did? Oh, no.
If this is some kind of practical joke, it's not funny. And I know funny. I'm a clownfish.
No, it's not. I know it's not. I'm so sorry. See, I suffer from short-term memory loss.
Short-term memory loss. I don't believe this.
No, it's true. I forget things almost instantly. It runs in my family. Well, I mean, at least I think it does. Where are they? Can I help you?
Something's wrong with you. Really. You're wasting my time. I have to find my son.
Okay. So basically, Molaison could not form new memories, kind of like this nice fish there, Dory. So, but funnily enough, these surgeries, the surgery that Scholby did in the 1950s, is actually been done, and it's quite successful. And it's done in many cases, in many centers in the world, and the chance of success is quite high, actually it's 85% or more. The trick is that nobody will ever remove 2 hippocampi from a patient, but you can take off one, and the other, if it is healthy, will take the functions of the one you took, right? So we know in our days that there's a surgical procedure, epilepsy surgery, which is basically removing the hippocampus that is starting the seizures, and this will stop the epilepsy, will very likely cure the patient without any major deficit. Why there's no memory problem? Well, because there's still one hippocampus left that will take the function that the one you took out. And the one you took out was pathological anyway, because one was the one involving epilepsy. So that's a very common procedure, and sometimes before doing the surgery, a team of neurosurgeons and epileptologists will decide which area they have to take off. Sometimes it won't be the hippocampus, sometimes surgeries can start from other areas, so they have to be really sure it is from the hippocampus or it is from another area. So what they do is they implant electrodes, which are like little needles, right, that go inside the brain. Sounds very brutal, but you have to think that they are considering the surgical procedure of taking a piece of the brain out to cure the patient. And these are patients which are in very, very bad situations. They cannot be treated with medication. They have a very, very pure life condition and so on. So they are very good candidates to get cured with epilepsy surgery. So in some of these cases, then, patients get implanted electrodes inside the brain for pure clinical reasons. And the idea is, let's try to find out exactly and as precise as possible where do the seizures start. And then let's see if we can remove this area to cure the patient. Now, to scientists, this gives us the amazing opportunity to study the brain from inside, to get recordings from inside the brain, which are done for clinical reasons again, but to see how neurons, and I'm skipping a lot of technical details, but to see how neurons will respond to different things, right? For example, looking at pictures, right? So, and the experiment is very simple. The recordings are being done, so the data is recorded 24/7, and I will basically go to the patient with my laptop, and I will show pictures, and I will see how neurons fire to different pictures. And if I have to summarize nearly a whole scientific career, okay, it might be this slide here. So these are recordings in the hippocampus, and this is what people call the Jennifer Aniston neuron. So whole career, hard work, just to end up showing this. So doesn't look very serious, but, well, that's me anyway. So what is that? That's a neuron that fired to Jennifer Aniston. That's it, simple as that. You show whatever you want, the neuron doesn't fire. Well, there are some technical details, but you show many things, the neuron doesn't fire. You show a picture of Jennifer Aniston, the neuron likes it, and the neuron fires. Now, if you want to forget for a second that it's Jennifer Aniston, that it doesn't look serious, that it's funny, and so on, look at this picture. Think carefully. This is something pretty interesting, right? Because you have 4 completely different pictures of Jennifer Aniston. I'm showing 4 here, but I tried 7, and it's exactly the same story. You have many different pictures of Jennifer Aniston, and the neuron fires the same way, right? The neuron doesn't care if Jennifer Aniston is in front view, in profile, wearing something with a background white, black, or yellow, or so on. As long as it is Jennifer Aniston, the neuron fires. So the neuron fires to her, not to particular details of the pictures. And that was quite surprising at the time, right? Because in neuroscience, we know that there are neurons that fire to visual features, right? Like color, orientation, and so on, faces, and so on. But nobody saw a neuron like this that will fire so robustly to completely different views of the same person, actually completely different pictures. And my point has been, well, this neuron fired to the concept, doesn't fire to a specific picture of her. We're doing an experiment with humans, and there's a very easy way to prove that this is the case. And we basically write the name. So I can write the name and see what the neuron does. I'll show you another example. This is a neuron that fired to Halle Berry, right? So, and Halle Berry at the time was releasing a film called Catwoman. So we also show pictures of Halle Berry dressed as Catwoman, and you can see, as you can see in the bottom, the neuron also fired to Halle Berry dressed as Catwoman. Fired to pictures of Halle Berry as well. I mean, I had 4 pictures of Halle Berry, fired to all, and to nothing else. And you see in the bottom right, the name, Halle Berry, and that was actually the name written in my computer screen. And whenever I show the letter screen, Halle Berry, the neuron fire. So there's nothing on the pictures. It's actually the concept that triggers a neuron. And another interesting thing is, well, I will show my neuron. I have my own. So this is a neuron that fired to me, right? I'm doing experiments with the patient. These experiments were done at University of California, Los Angeles, UCLA. So I went to the patient and I started doing the experiments, and one day I find a neuron firing to me. And it fires to different pictures of me, to my name, Rodrigo, written in the screen, and also saved by the computer. And this is what you see in the bottom right? This sound is actually the computer saying Rodrigo. And whenever the computer says Rodrigo, the neuron fire, right? Whenever the computer says, I don't know, Cameron Diaz, the neuron did not fire. So it fires to different sensory modalities. It fires to the name, it fires to different pictures. That's a conceptual representation. And this neuron is specifically interesting, not just because it's me. Well, actually, it is because it's me. Why is it interesting? Because the patient didn't know me before, right? So I don't meet the patients before they come to hospital. I do not meet the patients before we start doing the recordings. So maybe a day after I did my first recordings, I just found a neuron like that. So this means that this conceptual representation can be created very quickly, within a day or even less. How I'm doing with time? I mean, do I need to hurry? A few more minutes, okay. So we saw some movies today, and I said, well, I have to show you my favorite one, my favorite movie of brain science. And this is from a German director called Wim Wenders. The movie is called Until the End of the World. And it's about this woman going around with William Hart with this funny machine that is filming and at the same time recording brain signals. And they're doing this because there's a crazy scientist in Australia, Max von Sydow, that is trying to implant these brain signals into the brain of his wife through EEG recordings, actually, non-invasively, so that his wife can see because his wife is blind, right? So he succeeds in doing that, and basically these people are filming parents, family members and so on, so the wife gets excited that could see, how her daughter is doing, how she looks like, and so on. But then Max von Sydow realizes, well, we can invert the process. If we can implant images in the brain by stimulating externally, we can actually record the natural images from the brain and interpret them. And that's decoding. And see how beautiful it is. It's just 2 minutes again.
What's he doing?
He's trying to record his own dreams. The technology is the same. He takes his brain signals and turns them into pictures on the screen.
That doesn't look very promising.
We'll see.
At first, only Dr. Faber could see the promise of his experiments. He and Carl worked around the clock. But the fruit of their labor seemed to be nothing more than a chaotic rhythm of digital noise, colors, and lights. But eventually, shapes began to emerge.
Progress. A cacophony of brainwaves transformed into a symphony of colors and shapes. Biochemical images. If I were Sam, this would make me feel like honey. Music of the spheres.
This is so beautiful.
Beautiful. Wallpaper is beautiful. You're now looking at the human soul.
Okay, so how this links to my research, together with other colleagues at UCLA and Caltech. Well, actually, if you do see these neurons, if you do record from the neurons, the signal is so strong that I can tell you that the subject is looking at Jennifer Aniston, looking at Halle Berry, or looking at me. I only need to see the neurons, and I can tell you, among a certain discrete set of choices, what the subject is looking at. Not only that, I can tell you what the subject is thinking of, again, within these discrete sets of choices. And we show that. We show that if the subject thinks of Jennifer Aniston, the neuron will fire, and we can use some readings of the signals as we have, and some mathematical algorithms to tell you, well, the subject is thinking of Jennifer Aniston right now. And we can show this with success, which could be very useful. It has also a lot of clinical applications for example, for leukemia patients as a way of communicating with the external world. Okay, so I want to finish. I tell you many stories. I told you about Borges, Shereshevsky, HM, patient HM. I told you about these Jennifer Aniston neurons, but I want to finish. I will finish with Borges, but first I want to tell you what these neurons are doing. I don't want to leave you with the Jennifer Aniston neuron, which is very weird, where why would you have a Jennifer Aniston or a Halle Berry or this type of neurons in your brain? Well, the key idea comes from, again, patient HM. So patient HM did not have the hippocampus and could still have memories from the past and could still recognizing. HM could recognize people and so on. He could not form new memories. And these neurons are in the hippocampus. So my hypothesis, what we're trying to prove with experiments and so on, is that these neurons are involved in the formation of new memories. And now everything comes together. If you want to form new memories, things that you will remember in years to come, you will not be storing details. You will forget details. You tend to store concepts. The schnitzel, the cafe, the guy dressed in these things, selling me tickets to the opera. The details are gone. And this is what we call the building blocks of memories. So these concept cells are just the semantic memories, the representation of concepts that you will group together, you will link together to create the new memories. And I finish with Borges. He, at some point in Funes de Memorios, he described what it is not to be able to forget, not to be able to forget details, to get rid of details, and to abstract. So look what he says. He says about Funes, it was not only difficult for him to understand that the generic term dog embraced so many unlike specimens of different sizes and different forms, he was disturbed by the fact that the dog at 314, seen in profile, should have the same name as the dog at 315, seen from the front. Complete lack of abstraction. And here is for me the best piece, the best line of this whole story. To think is to forget differences, to generalize, to abstract. In Funes' crowded world, there was nothing but almost immediate details. Thank you.